Hi everyone. This week we are going to discuss the Ancova test. Hopefully you all have read your assigned readings, and so you have a general overview of the Ancova analysis. And so basically this statistical test is for designs that involve more than two groups to determine which group, if any, outperformed another, taking into account the covariate that is expected to influence the outcome. And so this is very similar to an ANOVA analysis that we discussed earlier in the semester. And so when we're looking at an ANOVA analysis, we are comparing differences, those mean differences among three or more groups. However, there's an additional component with Ancova where there's a covariate. There is some additional variable that could possibly have influenced our outcome variable as well. And so we're going to talk about this covariate is also known as a confounding variable. So typically, in that ANOVA analysis, we think of that independent variable, our three groups here, as being the exclusive influence over the dependent variable. And so the experimental model that we're using in this particular example this week involves administering participants who were involved in administering one of three treatments for 30 minutes. They either received the control, they didn't receive any treatment at all, they received PET therapy or meditation. These are for individuals who have been diagnosed with an acute anxiety disorder, and then we are measuring their pulse rate. So our independent variable is groups, our dependent variable is pulse. So, however, in a perfect world, we, science acknowledges that there are expected extraneous variables, extraneous factors that could influence their pulse rate. And so in the language of experimental design, those of you who have taken your research design class, you may remember the term confounding variables that were used, because this particular confounding variable could influence our dependent variable as well. However, in the statistical world, in statistical language, these confounding variables are referred to as covariates. So in this particular example here, in this Ancova example, a confounding variable of smoking has been introduced. And so suppose we discover that some of the participants in the relaxation experiment smoke cigarettes. And so cigarette smoking could be considered a confounding variable, as smoking influences the pulse rate as well. So now, instead of just the independent variable influencing changes in pulse, there's now an additional confounding variable, smoking, that can alter the data in the dependent variable. And so, as stated earlier, Ancova is similar to an ANOVA type model. However, an Ancova adjusts the results according to the influence of the confounding variable introduced. So in other words, if we have data pertaining to a known confounding variable, such as the influence of smoking on pulse rate, Ancova can statistically alter the results so that it neutralizes the effects of neutralizes the effects of the identified confounding variable. And so this provides a cleaner image of the effect that our independent variable has on the dependent variable, as if the confounding variable smoking has been statistically removed from the picture. And so the results will look like as if you have ordered an Ancova test, except the figures will be adjusted to account for the influence of the covariate smoking. Now, one thing to remember, something very important to remember, is that the covariate that you include in your analysis, in your Ancova analysis, must be a continuous variable. And so let's notice that, so for in this particular example, smoking is our continuous variable, and it's going to be defined as the number of cigarettes the participant smokes in a typical day. So let's just take a peek at our data set. So here is group, okay? Our groups, we have 1, 2, and 3. This is our independent variable. Pulse is our dependent variable, their pulse rate, and then smoking is our covariate. Now, 0 is, so remember, this is the number of cigarettes smoked in a day. So if it's 0, that means that they are a non-smoker. And then we do have some individuals who do smoke, and so this we have indicated the number of cigarettes that they smoke in a day. And also, in order to facilitate the integrity of this analysis, there should be a reasonable rationale for including a covariate. For instance, there needs to be some reason to expect that the covariate can be gathered accurately and that the proposed covariate is rationally associated with the dependent variable. So, such findings may emerge from sources such as evidence-based literature, expert consultation, prior experience, even common sense, maybe based on the events that occurred during your research study. You may have noticed that there's a particular variable that could have influenced your dependent variable as well. So in this particular study, here is our group, people with acute stress disorder. They're randomly assigned to one of 3 groups. Here are groups that we mentioned earlier, and after 30 minutes, the pulse rate and mean daily smoking is recorded for each participant. Here is the null hypothesis is indicating that there is no difference in pulse rates across the groups. And then we have our H1 stating that there is a difference in pulse rates across the groups. Now, the statistical pretest checklist for the Ancova involves 2 major criteria. We have our homogeneity of regression slopes and homogeneity of variance, which we will use the Levene's test for. And so we're going to run the homogeneity of regression test prior to our Ancova test, and then our Levene's test will be run while during the same time that our Ancova test is run. So let's go ahead and run our homogeneity of regression slopes test. Here is our data view window here. So we are going to click on Analyze, General Linear Model, and Univariate. We're going to move Group to the Fixed Factor window, move Pulse to the Dependent Variable window, Smoking to Covariate window. Let's click on Model here, and we're going to create a customized model. And so first we'll move Group, and then Smoking, and then we want to move both. Let's click on Continue. So notice We want to keep our type here as interaction. And let's click OK. And so we are going to inspect the test of between subjects table. Test of between subjects effects table. And so we want to specifically look at the significance value for our interaction model, our group and smoking interaction model here. And so we want to look at the significance value, which is 0.488. And so this is greater than our alpha value of 0.05, indicating that there is no statistically significant difference in the regression slopes among the variables involved in this model. And so hence the assumption of homogeneity of regression slopes is satisfied. So in other words, the trend of the values contained in each variable concurs or runs virtually parallel with each other. And so now the remaining pretest criterion, the homogeneity of variance, we're going to process it during while we run our Ancova test. And so let's go back to our data view. And so we're going to click on Analyze, General Linear Model, Univariate again. And so we already have in our univariate window, this is already correct here. Now let's click on Model again, and now we're going to specify the full factorial. And so this is going to discard the model that involved the group and smoking interaction term that we created when we customized it. And so let's go ahead and click on Continue here. And now in this particular menu, let's click on Options. And so now we're going to move Group into the Display Means For window. Let's check the Compare Main Effects, because this is going to give us our pairwise comparisons that we complete when we complete an Ancova test. And we're going to do something similar for our Ancova test. Now, in this particular confidence interval adjustment, we're going to select Bonferroni, and we will select homogeneity test. This is where our Levene's test will be completed. Click Continue and click OK. Here is our Levene's test here. So the significance value is 0.691. This is greater than 0.05. It's indicating that there is no significant difference between the variants. And so our assumption is satisfied here. And so now let's look at the test of between subjects table. And so we want to look at our group variable here. And so when we look at this particular row here, when we look at our significance value, this is indicating that a statistically significant difference has been detected among the groups. And so for specific details on which group outperformed which ones, let's scroll down to our pairwise comparisons table. And so our pairwise comparisons table, it's read in the same way as the multiple comparisons table that was produced in the Ancova post hoc test. And so these results reveal a statistically significant difference in the adjusted means between control and pet therapy. and this is showing a significance value of 0.029. And so the actual adjusted means for the pulse rates for each group are shown in the estimates table here. And so remember, these means are adjusted because it's taking into consideration that covariate. And so notice here, there's that little this little superscript here, A, and it's indicating that covariates appearing in the model are evaluated at the following values, and so each of these means have been adjusted. And so it looks like this particular group is the only group that has significant differences. And so sometimes in order to clarify the hypothesis resolution process, sometimes it's helpful to organize the findings in a table and then use an asterisk to flag the statistical significant differences. And so if we go here, let's go back. I'm going to scroll down through my slides because these do have the step-by-step procedures on how to complete the Ancova analysis. I'm going to scroll down to this particular slide, and this shows our findings that were shows the differences between the groups. So we had, let's go back to our output here. So here is our table that compares the results. Sorry, there was a typo. I had to adjust. And so this shows our results here, and it shows that we have one pair of groups that are statistically significant, our control and our pet therapy group. And so now we can revisit our hypothesis. And so because we have discovered a statistically significant difference among at least one pair of the mean of the pulse rates, we can reject our HO and accept our H1. And so specifically, pet therapy outperformed the control group in lowering the pulse rate at a p-value of 0.029. And so here is our abstract. This gives us context on the particular study, and then this tells us first we list our descriptive statistics showing our means and standard deviations, and then we do indicate our covariate controlling for smoking status. The mean pulse rate of those in the pet therapy was 0.417 lower than those in the control group. And so similar, the mean pulse rate of those in the meditation group was significantly lower than those in the control group. So we can discuss that the pulse rate for were lower for those in the pet therapy group and in the meditation group, but notice we do state that the meditation group was significantly lower than the control group. And so we can suggest that pet therapy and meditation are viable non-pharmaceutical supplemental treatments for those diagnosed with acute stress disorder, or we can just state that maybe those who received meditation would be more of a viable treatment option, since this particular treatment option was the only one that received significantly lower results. And so that is pretty much it for our Ancova test. And if you all have any questions, please let me know. Thank you.